and just fucking start from scratch and collect a bunch of data and try to find some correlation between water temperature, air temperature, humidity, like all these variables, altitude, height, like whatever, just collect the data and see where it comes out. You know what I mean? But we need something standardized to actually say, hey, we need a standardized data collection technique is what I'm saying, to be able to say anything useful about what the observations are. And I think me and you were talking about the different distances of like moving away from or toward or away, like in something that shows an inferior mirage. I have done some up down. So I took some 15 foot above sea level, then on like 120 feet above sea level, on the nearly on the same sight line, and the inferior mirage didn't go away when I did this, so you can still see it.
But Indio, Wallace, that's how Wallace accounted for refraction in the Bedford level. He went up 13 feet.
Oh, really?
Yeah.
He accounted for refraction by going up 13 feet.
Yeah. Yeah, because Robotham did it too low, and that was extreme refraction because it didn't line up with the globe. And then Wallace.
How many times did they do it? How many times did they do it?
Enough until it matched what they thought it would on
20, 50? Oh, okay.
They did it till it matched. You mean like the freaking South Pole pendulum? Oh, it's going the wrong way. Try again. Oh, it's going 2 times too fast. Try again. Oh, it's just right. The freaking Goldilocks freaking version of science. Someone's been sleeping in my bed. This experiment is just right.
It's kind of like the Walter Bislin slider.
Yeah, exactly.
Oh, look, turns out there was exactly this much refraction on that day, because now, there's no hidden height if I slide it to here, so there was this much refraction on the day. Debunked, flat Earth.
Dude, listen, I just take, like, when they say it's a simulator, no, dude, it's not a simulator. That's a graphics program, right? That will distort the 3D world, right? So you can just distort it with the sliders. We're just going to distort the geometry because that's all it does, right? It just distorts the size of the ball that is part of the 3D geometry. That's all it does. It doesn't actually calculate any refraction, right? It just does the effective radius. And it just makes the ball bigger. Doesn't do anything else. Doesn't simulate anything.
And it actually says on his website that when you slide it to 1, it means that there's so much refraction that the radius would be so big that the Earth would just look flat. And you have to slide it to 1, or close enough to 1, for most of the observations.
And his if you click the flat Earth checkbox, that is the 3D element that's in that is a giant disk. I don't know if anybody's tried to compare his flat Earth disk checkbox to the giant freaking globe that looks flat. Have you ever? I mean, I could do it right now, I guess. Just compared to see if it looks the same, like the flat Earth versus flat globe.
See, DJ took out Perfect Storm from a band forever.
He asked for it.
Yeah. He was asking for it, yeah.
Oh.
Yeah, he was ban evading today. That guy's just so dishonest and ridiculous. We got enough content out of that guy. I think he just comes in, kind of takes over the chat and just spurgs out constantly. It's just like incoherent.
Is that the piano
Dude,
player? The one that plays the piano?
no, he's Goldberg Jesus. He's trying to bring everybody back to Gold Jesus or something. Like he's like literally. He said he's in here to save people from flat Earth.
So yeah, that guy, Storm, yet another person afflicted with anti-flat Earth derangement syndrome.
Yeah, there's a video of a amateur rocket being shot up into space, and you can clearly see a curve, but these guys just always change the subject or ignore it.
That means it will be also on the ground, if you can see
start
from
with
the
the whole
rocket.
Bigfoot unicorn shtick.
Yeah, that would be the curvature that we're asking for the measurement of that no one has. That
Okay,
curvature.
but you can see it. Like,
okay, so why can't you measure it?
Something.
So, are we trying to disprove flat Earth, or are we trying to prove globe Earth here?
Well, they'd be the same thing.
There's two sides.
In order to disprove the flat Earth, you would need to prove a globe because.
Okay, so where are the globe tards? Are there any globe tards in the call?
Yeah, we're just speaking to a few of them. Okay. No, the first guy was cool. What is it, Mansky? He's a big-time globe head. He's been coming here for months and just like sideshow Bob walking on rakes 24/7. But the first guy, who was that? Because he could actually hold a conversation. So we've not got someone from the flat Earth side who can pick this up. Who's on TWN? Says who? DJ?
I am, but I may not be for very long.
Drace?
What I would say is that if that imagery that Mansky's talking about is indicative of a sphere Earth with a radius of 3,959 miles, and when we go to a 20-mile lake, or we look across a 21-mile body of water, we wouldn't see clear to the other side. There would be a horizon at about 2.7 miles and a curvature drop of about 260 feet at the other end. But that's not what we find. So sorry. The imagery.
Can we set aside the curvature drop for a bit? Because I'm presenting here a photo of the Earth, and you're saying that it's been manipulated. Is that correct?
I'm saying that if it is indicative of a sphere Earth with a radius of 3,959 miles or a circumference value of around 25,000 miles, then when we go to a large body of water, like a lake, and look across 21 miles of surface of water, we wouldn't see clear to the other side. There would be a horizon at 2.7 miles and a curvature drop of 260 feet at the other end. But there isn't.
That's just a statement that you made now.
Yes, correct. So any imagery that's presented to you as some kind of evidence or a claim that it is representative of the Earth as viewed from a very far away, and it comes with those values of this Earth's size, its radius, its diameter, its circumference, then when we go to a large body of water, like a lake, and we look across 21 miles of surface of the water, we shouldn't see clear to the other side, but we do. So therefore, do what you will with that imagery. Think about it as you will. If you want to just rest your faith on that unverifiable image, that's on you. Right? But meanwhile,
well, you've got to actually explain the steps.
Yeah, sure.
You can't just tell me that because I'm looking at a circle with some kind of radius that this needs to happen.
Right, so if that is the Earth and its surface is curving, then there's geometric consequences, right, to what we will see and what we can measure on the surface here on Earth, right? Meaning there's a curvature rate to it. So roughly 8 inches per mile squared, which means over a distance of about 20 miles, there would be a curvature drop of around 250 feet. Do you understand?
Right.
How much drop is there? How much drop is there?
I'll go to the Earth curve calculator. We've got, I don't know how to use this in conjunction with the image, whatever.
Because if the Earth doesn't curve as much, that means it would be an even bigger globe.
True. Look, if you're just looking at the image, if it was, for the sake of argument, not touched at all, right? No Photoshop has been altered. They just took it off, like they printed it as soon as it was taken, right? And nothing happened to it. Would that mean we live on a sphere? If the image was true, mind you.
The correct term, I think, is oblate spheroid, but yeah.
Hypothetically,
So the image,
if it was true,
the image
it'd be true.
has been, changed.
If the image was true, the Earth would measure accordingly, curved. However, besides doctoring, there's a very simple explanation, and that they used a wide-angle lens which curves horizontal lines. So if you look at the video, early on when they're close to the ground, does the horizon appear curved? If yes, then this is a wide-angle lens.
I don't know, I don't see a video, and I'm not talking about a specific image. There's lots of images of Earth.
Yeah, and we've gone through you're welcome to try to find one. We've gone through thousands of them, and we have hundreds of ones that don't have a wide-angle lens, and they show flat horizons.
Can you show us that?
According to the math, the ISS is too low to the ground to have the Earth curve, and so they need to use wide-angle lenses to make it appear curved.
Can we all agree that you believe that the image is doctored?
No, I didn't say it was doctored. A lens effect does not mean the image is doctored.
What about an image like without a wide-angle lens?
I'm not. You have to show me a specific image for me to claim it's doctored or not. Okay? It doesn't really matter because the surface determines if the Earth is curved or not. And so, if you have an image showing a unicorn in your backyard, and then we go to your backyard and there's no unicorn, I am not obligated to believe in your image. Do you understand?
I can't actually send anything in the chat. I can't send an image.
So you don't understand?
No, I do understand. I'm trying to send an image and I can't.
That may be an issue of just being too new to the server, so you might have to, participate more in chats until you level up, and then they'll grant you that access.
Right. So, do half of you believe that the images are doctored and half of you believe that it's using a wide-angle lens? What is the actual consensus on this? Is there a consensus?
How would there be a consensus on multiple images? Each image is specific to that image. We don't have an imaginary consensus. We're not a cult like the cult you come from. We're not a cult like the cult we left. We're just the people who left your cult, okay? Get it through your brain.
Okay. You can also decide that none of the images are indicative of a globe, that they're either wide-angle lenses or doctored. They're not mutually exclusive. I'll just send DJ the image, whatever.
There's many potential causes for the images. you like us can simply.
This is the most
test
standard
the
image. I
images.
didn't like.
I understand. I'm just saying, any image that contains the globe in it, you can just go test it yourself. Does the reality curve like the image is presenting to you? If it does not, the image is not true, regardless of how it was made.
Right. So, okay. Some images are made with a wide-angle lens, and some are doctored. Can we agree on that at least?
Yeah, sure. NASA admits they, like, we have a link here for you from NASA to graphics designer working for NASA who created the blue marble image. They freely admit that they doctor some images and create some images. Many people believe those images are real images. There are other images they claim are real images, and we simply test the surface. So we don't care what other people claim when they don't have any evidence backing those claims. The evidence comes from reality conforming to your images or not. If reality doesn't conform to the image, then the image clearly isn't true regardless of how you derived it. You could have created it through an AI. Whoa! That doesn't mean it was like doctored by a human or using a wide-angle lens. There could be other methods made to create images, like what was he called again? Math Powerland. One of the earlier flat earthers. He claimed to have worked for NASA making paintings, very realistic paintings of globes, and he ended up making a comedy routine after he stopped working for NASA, and was like, "Is this a painting or a photograph?" And he had globes, and he made fun of this because he was and ended up becoming one of the earlier flat earthers, because his paintings were so realistic that people believed they were real pictures of actual globes in outer space. But we're not making claims about the entirety of supposed space pictures. We're testing those claims. The pictures themselves are the claims, and we're testing the claims. Do the claims hold up in reality? And they don't. That's the simple.
I'm not doubting any of that, okay? I'm simply saying, all right, let me put this as cleanly as possible. The images could have been painted, doctored, photoshopped, created pixel by pixel, manually written in a text editor, all right? It doesn't matter. An image as of 2026 has no value whatsoever. It is not proof, all right, alone. But let's say, for the sake of argument, that an image was not doctored, it was not painted, it's not fake, all right? For the sake of argument, all right? If the image was actually real, taken on a spacecraft outside of Earth, right? If all of those things were true, never mind that you don't believe in them, just say that they were.
Yeah, I'll
the one I
you,
posted.
if all of those things, if
I haven't finished.
were true, okay, sorry.
All right, if all of those things were true, and you just take any random image like the one I sent you, right? That would indicate that we're on a sphere, right? But I know you don't believe all of this.
No problem. If we assume all of this is true, and we went out into outer space and we saw the Earth as a ball, the Earth would measure as a ball on the surface. It doesn't, so your hypothetical doesn't make any sense.
Right.
And your image doesn't make any sense.
What's wrong with it?
Well, on one half of the ball, you have Africa.
And that's a problem. Why?
Well, on the other side of the ball, you have North and South America, Asia, Europe, Australia, Antarctica, all the oceans and seas surrounding.
So?
That's why it's a problem. Think about it, sir. Use brain.
On the other side, we have too many things. I'm pretty sure if I went on Google Earth, on the other side, we have too many things. So?
That's why it's a problem. Think about it, sir. Use brain.
On the other side, we have too many things.
Brain.
On the other side, we have too many things. I'm pretty sure if I went on Google Earth and I can get this exact perspective and everything will be fine. In fact, I'll look right now.
Well, then you have the same problem with Google Earth.
WebGL is not supported on my browser. That's great.
Senator, this stuff seems to be going in one of your ears and out the other. Good luck to you, dude.
Hello, guys. How are you guys?
You just told me that my image makes no sense. Out of the blue.
How are you, bro?
I'm great.
Yeah, it makes
Where are you
no
from,
sense
guys?
because this is not something.
Where are you from,
that
guys?
Sense. Sorry. I'm
Where are you
responding to
from?
him real quick, and then I'll get.
No. Respond to me.
Yes.
Quick.
Yes.
Where are you from?
No. First, I'm responding to him, and then I will respond to you. Don't make me mute you. So it doesn't make any sense because what you experience is a flat, non-rotating world. You see the stars and the sun move in the sky, and you experience the world as a locally flat plane. That's how it's described, that's how it's mathematically used, that's how we function and use the world we live in. However, there's this belief that the world curves beyond what we can experience, and that special people can go outside the globe and experience it as a globe. Meanwhile, you, the plebs, cannot. And so you just have to believe in the superior people, and then you are enlightened because you are part of the religion of the globe. Sorry, we don't buy into that. We actually go out and test their claims, and their claims fall flat.
Unintended. I'm kidding. Yeah, I just realized that I was gonna make a different point, but then I fucked it. I'm sorry, but I don't follow with this whole religion thing, right? With the globe people.
Yeah, it's a globe religion. If you didn't know, the globe religion started as a cult within Pythagoras as a secret doctrine of the Pythagorean cults, and then spread into the mystery schools of Greek, ancient Greek, and our whole current worldview is built on this ancient mystery cult and their secret doctrine. And that's what everybody's been programmed to believe, even though they don't have actually any evidence. All the supposed evidence for it is just logical fallacies, and that's why they removed logic from your curriculum so you didn't understand how you're being manipulated. And then
they removed logic from the curriculum.
Yes,
that's
they essentially
not true.
Essentially removed logic from the curriculum. You only get a primer and slight education on it if you go into philosophy, but even then, it's drowned out by all of the different aspects of philosophy. back when we had the trivium and the quadrivium, logic and rhetoric were some of the primary things that they taught children, and so they were better equipped to identify logical fallacies. Meanwhile, we get taught Aristophanes, for instance, if Earth is a sphere, shadows would act like this. We see shadows act like this, therefore the Earth is a sphere. This is circular reasoning, but because it's dressed in math, it's dressed in authority, people don't realize.
That's what I've been trying to get at with my whole sphere photo. The point of the sphere photo is not about proving the existence of a sphere from just a photo. It's about getting you to acknowledge that you believe in someone that is oppressing us, controlling us, and feeding us false ideas.
I don't need any belief in that because I can just go out and measure the world and see that someone's not telling me the truth. For I don't know his reasoning for not telling me the truth. Maybe he's just confused. Maybe he's a dumbass. Maybe he inherited this lie from some other guy who might have been malicious. I don't know. I am not them, but I can test the fruits of their labor. I can test if the Earth is actually curved or not, because we have access to the Earth.
You can't be making this whole thing about us not being taught logic in school, about a cult created in ancient Greece, about them wanting to control you, and then just go on and be like,
no. Them wanting to control you, that's you putting words in my mouth.
Well, not you specifically, but it was said in this voice channel earlier.
Yeah, that's because we're not a cult like you. You come from a cult where there's a unified belief that you have to believe. We are an independent group of researchers who all have different opinions and beliefs. However, the only thing we share is the empirical, scientific, and logical necessity of reality. And so we teach each other logic. We go through science and physics. That's what we care about. We care about the empiricism, the measurements. If the Earth were measured curved, we would all be globers.
You just can't do that. You can't call me, you can't say that I'm in a cult started in ancient Greece and then say you're just an independent group of researchers. You can't have it both ways.
That's just how it is, because we are not a cult. We don't have a unified belief system like you do. You have one, and you are here policing for your belief system because you have a cognitive dissonance when being faced with the idea that your belief system could be wrong because you were raised in cognitive ease. You were raised with the globe being in all of your programming, all over entertainment, in your education, and you were never presented any alternatives. You were presented this as it was a concrete reality, and so it shaped your ego and your worldview as you think you live on a ball. You think there's outer space and other balls you could go to, and maybe aliens out there, and it creates this whole worldview for you, where you're like random accident of the universe.
If it's so easy to understand, or maybe not to understand, but if it's so observable and measurable and provable that we are on a flat Earth, then why is the consensus different? Why is flat Earth a minority and globe Earth the majority?
Because there's billions of gullible people just like you.
It's actually very easy. In the 1800s, there was a resurgence of flat earthers. In the 1700s, there was a resurgence of flat earthers, and there's always an opposition to this, and that's because the cult, the secret knowledge, the holders of the secret knowledge, we know how the world is, and if it's not how we thought it was, then we were wrong. We were telling everybody things that were wrong, and it's hard to accept that. That's sunken cost fallacy. So there's just human psychological reasons when people get caught up in beliefs. You can see this around any belief, like Scientology or any other thing, where people believe something so hard that they just don't look at reality for what it is. They try to insert their belief into everything, and when it doesn't matches, they just find some excuse to try to make it match. And that's what we keep finding. We wanted to believe the Earth was a ball. None of us wanted to be a flat earther, okay? It was most of us who came to this wanted to debunk them, and so we were like, okay, yeah, let's go out and test it. Well, like we'll figure out one way or the other, and just confirm the globe again and again and again until the flat earthers concede. However, what we did was confirm that the Earth isn't a globe over and over again, and eventually we just had to scratch our heads and be like, okay, like who do I talk to? It's far easier to convince people of a lie than to convince people that they've been lied to. And I don't really expect you to believe me or us. I just want you to think about your own beliefs, and then be critical of your own beliefs. And then, as you're out and about, and you can look out over the sea or whatever, and you can see, wait, I can see way too far for the globe, and that might cause some interest in science and logic and reasoning, and you might dig into this and figure out that the Earth isn't a ball, but it requires you to find it within yourself the desire to actually search and learn and test these things, because nobody's going to give you all the knowledge. You think the people who want to maintain power would give you all of the knowledge when knowledge itself is power?
See, there you go again, making claims about people holding the power for themselves. Like you just said that. You can't unsay it.
No, this is just basic human psychology. I'm not claiming a grand conspiracy. I'm just saying there are people in this world who have narcissistic tendencies. There are people in this world who have sociopathic tendencies. There are people in this world who are greedy. There are people in this world who are selfish and don't care about humanity. Like, there's many people who do, but the naivety of humanity and most people is to think there's no bad people in the world. There's no bad people who want to keep an advantage over you. And I don't presume to know who those people are. All I know is that I can test the surface, and the surface doesn't match what they told me.
And everybody knows there's corruption in government.
Yeah, my sister says everybody knows there's corruption in government, and we can quote her on that. I mean, it's not hard to imagine that some people are malicious, and I'm not saying that the whole globe idea is a malicious plot. It could be, but it could also just be a massive misunderstanding, and people building on that misunderstanding because they believe in the authority and the accolades of the ones before them. They think they're standing on the shoulders of giants.
Or it just could be true.
No, we measured the Earth and it isn't a globe, and so it cannot be true.
Look,
if
the
it's
two
so
main
true,
reasons.
If it's so true, why do you and this printer guy resort to illogical circular reasoning and just wishful thinking?
We don't see it as illogical, wishful thinking. We see it as logical and reasonable.
Okay, give some logic. That's not your. No, dude. Let printer flounder. But he's demonstrating his own illogic. Have you not been listening, Matthew? What has printer? What argument has printer given that's logical?
I'm not. I don't want to butt in on their.
Okay, well then be quiet.
Let them continue. Okay.
No, don't be quiet just because this guy told you to.
It's not logical, Matthew, to say that circular reasoning is logical because you believe in it. that's so far from logic. You are a teacher, bro.
The two main reasons you've given me as to why people actually no, that's like there's a lot of reasons you've given me as to why people don't believe in flat Earth, is because, well, I'm just gonna list them all. That's the way they grow up with. That's what's been taught at school. It's cognitive dissonance to change your ideas. It feels bad. You don't want to feel like you're wrong. And that's also what the cult feels. That's why they don't want to change their ideas, because they're also going to feel bad.
What? The first part was all good, but what the cult feels, I don't remember saying. I don't remember personifying a cult. Yeah.
Oh no, you did say I was in a cult, and you did specify that it started in ancient Greece.
Yeah, I call the globe religion a cult. Yes, that's correct.
And then I asked why the cult hasn't changed its views. You said that they didn't want to feel like they were wrong.
Yeah, that's called the sunken cost fallacy. Like, once you start doing something, you prefer that to have been the right choice rather than the wrong choice. And so humanity generally has this bias where you try to keep up with a broken relationship, even though at the start you should have seen the signs that this was never going to work out. It's just basic psychology.
You know, that's difficult to argue with. To argue that these points are invalid would be really hard, because it is hard to change your opinion.
Listen to him rationalize. Crazy.
I don't even blame them. Like, it's tradition. We were raised in this. Like, you see this all around the world with other kinds of traditions. People are raised in this. It's really hard to just let go of your tradition, the thing that you feel like is a part of who you are. It's very familiar, the globe. Like, we were all raised on sci-fi, on the TV. Many of us had rockets and globes in our cribs.
My co-rationalization is noted.
Yes.
You know, there's a lot of aggression towards globe people.
Dude, don't be a snowflake. I don't listen. I pity the fool.
No, come on. You've got to agree.
No, dude, I was once just as brainwashed as you are.
See, you're calling me brainwashed.
Okay, I'm calling myself previously brainwashed. That's what you're not hearing.
No, you said you're just as brainwashed.
You're to be offended by everything. Don't be.
I'm not offended. I'm not actually offended. It's just
okay. Good. Then move on with it.
Yeah. Maybe. Never mind. Forget about that.
So, Printer, shame on us for being.
He's showing you his perspective, like just like I was showing you my perspective. Like, from my perspective, having left the globe belief, I felt like it was like a cult. And now interacting with the people from the globe belief, it feels even more like a cult because of how they react and how triggered they get just by the idea that some of their foundational ideas about how the world is are wrong, because they put so much faith into this whole system.
Yeah, we don't want to stereotype you, right? So we'll try to avoid that. This is what we've gathered from countless conversations and even being introspective ourselves about how we've behaved when we first encountered the information. So we don't want to project that onto you. This is just what we've observed, that the globe belief is devoid of any empirical or logical foundation. And everything that tries to defend it usually is from a place of either anchor bias or, I don't know, wishful thinking, just a desire to stay on that side for whatever reason. I can't divine anybody's reason for wanting to hold a position that is devoid of empirical evidence or logical consistency.
But they have that illusion of logical consistency or internal consistency within their model. And because they don't understand what a reification fallacy is, they think the model represents reality. And so, because they never were taught deeply logic and how fallacies are so they could identify them, they end up just accepting these things, and especially because it was taught when they were so young, it creates the foundation when they were too young to actually question it. So when you get further in schooling, you're already building on that foundation you assume is true, and if you question it or you don't write the right answers, they fail you on the test. And so it becomes a very programmed machine that pumps out people who believe certain things, and then you find out over time, working in your field, that a lot of the things they taught you in school were outdated, and we're actually moving in this direction now. And so the school creates a certain idea in the general public, even though, like, we get a lot of people in here who think Newton, for instance, still works and is a thing that is believed within physics, when it's a convention that's already been falsified within actual physics. But most people don't know that because they don't go far into physics. They just hear the popularized things on TV or on TV shows and form their opinions based on that.
I mean, look, I'm kind of back here into a dead end because there's really two sides to the flat Earth theory that I'm aware of, and one of them is the experiments, and the other is that that we've been raised wrong, that we've been taught wrong, and all this other stuff. And we can't really seem to agree on any of those. We can't agree on gravity. We can't agree on the drop-off thing, the drop-off distance. I don't even really...
Well, we have no problem agreeing on gravity with many globers. The problem is most globers don't know anything about gravity and don't know that Newton's been debunked, Einstein's been technically debunked. And so they have 79 new theories within the highest levels of academia concerning gravity. There's like 20 different ones that are competing, and are some of them at the highest levels, and some of them are like modified Newtonian dynamics or modified versions of Einsteinian or quantum gravity or holographic gravity. So there's a bunch of different theories right now about what gravity is. But it doesn't change the fact that flat or globe, we all have a downwards vector and things fall. That's just what happens. The effect is the same regardless of your imagined geometry. Gravity has never been a problem. We can even use Newtonian or Einsteinian gravity with flat Earth. All you got to do is change the mass distribution underneath the ground, and it will work the exact same. So the effect is the same regardless of the geometry. The assumed cause has really nothing to do with the geometry.
So there is gravity. Like we're
Well,
not.
yes, there is there's
There's an
little
effect.
g. Yeah, there's little g, the effect. We all observe that. Everybody does. There's a problem here with languaging in that people call little g, the effect, gravity, but they also call the cause, big G, gravity. And so when you have the same name for the two different effects or two different things, like because big G isn't really an effect, it's just an assumption about what causes the effect because they can't test the assumption. And that's why we end up with so many different theories because they can't test it.
If I can add to that, Drace, quickly, there's also an issue in the language when it comes to the claim about, oh, it's proven because we've done an experiment to prove it, right? Wherein in this sort of experiment, in this context, what they're calling an experiment, it would basically be a measurement or a test of sorts, whereby, they drop a thing, it's in a vacuum, okay, they measure the density of this thing or calculate it, whatever, compare that with the surrounding medium, and then they drop it, and then they time, the time it takes to fall. They call that an experiment. You know what I mean?
What's wrong with that?
There's nothing wrong with that setup. You're measuring the time it takes from point A to point B. Perfect. You have all your things sorted out. You have your control variables and shit like that. The height, the density gradient, not gradients, differential, et cetera, et cetera. Right.
The confusing measurement with experiment. Measurements are perfectly valid forms of gathering true knowledge, or because they translated science is now knowledge and not the correct application of the scientific method. So you can call it science within that perspective. However, it's not doing an experiment as much as it's just trying to measure something and control the other variables that could affect the measurements.
Yeah.
Right on. Yeah.
There's also a contention.
If I may, right. He asked, what's the problem? The problem is, again, like I said before, and like Drace started off by saying, there's a problem in the language. If you go around saying, I did an experiment to prove gravity, look, I dropped my phone, there's gravity. Okay. Versus, I did an experiment to, test what causes water to boil. Those are two very distinct, areas of inquiry, number one, but also the setup to actually get a result, right? The results are very different, right? Not to mention the process of achieving that result. So to call them or to label them as being, worthwhile being put under the same umbrella is faulty. But we do it kind of colloquially anyway. Go ahead, Tita.
I mean, they're two different experiments, aren't they? Why?
One's not an experiment.
One is an experiment, one is an observation. So, you can observe a measurement and you can measure something and get good information out of that. However, an experiment is something to establish a cause and an effect, or cause to an effect. And so you start with finding an effect in nature, like things fall. And so you presume, what's the cause of falling? And you might think, well, if I scratch my head and jump, that makes things fall. Retarded. But that would be your positive hypothesis. And when you try that, and it doesn't make things fall that didn't fall before, then you realize, well, I proved the null hypothesis. I proved that my presumed cause wasn't true. I was just imagining some garbage, and it had nothing to do with what was happening. And that's why the scientific method is so valuable, because you presume the cause, and then you manipulate that presumed cause to see if it has an effect. If it has an effect, like in the case with the water boiling, you heat the water and it starts to boil, you have proven that heat causes water to boil. But when you just measured something falling, you did not prove the cause of that thing falling at all. You just measured something fell. And then if you then take that measurement of the thing falling and then make a bunch of assumptions and mathematics and create a whole model, you can create 79 different models of gravity through different mathematics based on the same effect, but because you never had a cause to test, you can't validate if that cause was the cause of the effect. Does that make sense?
Sorry, I lost you. That was too long. Could you simplify it a little bit? What was your main point?
Let me try. Okay. In one context, you're literally manipulating a thing that you are supposing is causing the other thing to happen. Right?
All right.
Right? You literally manipulate the temperature, keep the pressure constant, whatever, and you see that eventually the water boils. Okay?
Okay.
In the other.
Right? And in the other, you're not manipulating shit. You're just dropping something.
Just observing the effect.
Yeah, and you're measuring how long it takes. You're not manipulating the thing that is supposedly pulling the thing down to see if it actually pulls it down. Or changes.
How would I do it correctly?
Just quickly, that leads to an assumption that this, whatever the reason for your object falling, has an influence over all matter, right? But observably, we don't see it influencing gas.
Yeah. So from this, you can extrapolate out and assume a bunch of stuff, and that's where the storytelling starts to come into play, right? So whereas if you could, for example, say, okay, the mass of the Earth is pulling the thing down towards it. That's your hypothesis, right? That would be the variable responsible for the effect. If you could, hypothetically, manipulate the cause, i.e. manipulate the mass of the Earth, and witness a variance or a change in the rate at which things fall, right? Let's say, I shrink the Earth, in half, and I witness the acceleration of the thing downwards cuts in half, say, just for example, or I reduce it by 90%, and the rate goes from 9.8 to 0.98, right? Cuts that in 10. Shit like that, right?
But even if you could do that, right, you still haven't. You've just demonstrated that there would be a relationship between an object's size or its density or its mass or whatever, right, versus the density or the mass of some other object, right?
Yeah.
You still haven't really established what that interaction is exactly, because Einstein came along and said, right, without the experiment, well, Newton was wrong. There is no force or field emanating from the matter just because it's matter and grabbing onto other things and influencing each other that way. No, he says there is no interaction between those objects at all if there was no space-time.
Right on.
So he's got a third variable involved.
Yeah. There's a lot more to it, right? But what I outlined would serve as a good stepping stone in that direction, right? Whereby
shrinking the Earth down.
I'm just giving you a silly example, dude. And the whole point is you can't actually do that.
Exactly. Right? Is there an experiment I can do?
In this context, no. Because supposedly the Earth is responsible for this thing, or the Earth's gravity is responsible for this thing. Well, the mass, I should say, excuse me, which causes the gravity. So there's an assumption that those things are intrinsically linked. Right now, implicit in that assumption in the first is that there is a giant mass, for example, in the heliocentric model, floating in space, in the first place. Okay, that's the kind of sneaky motherfucker that you kind of just have to ignore or just absorb and forget about. Okay.
There's an experiment you can do for specific gravity.
Right. Yeah, there's stuff that you can test, dude, in this fashion that we're talking about. This is one such that you can't in this sense. So it's as if, over time, it was recognized that you can't really do that in that sense. So the rules of the game, say, or the rules of the field kind of like, adjusted or they laxed a bit, So as to allow this, context to be enveloped in this field. And, okay, we can't really fully experiment in the way that we know we should, but fuck it, we're just going to do it anyway this way with the rules relaxed and still, qualify it as being science. It's almost as if that's what happened. I don't know. Seems like
they
that.
They freely admit this at the highest levels of academia. They'll say, like you'll ask Neil deGrasse Tyson, what is gravity? And he'll say, I don't know. Because at the highest levels, they're like, we don't actually know what gravity is, but we have a pretty good guess, and we have calculated the effect, so we can like model it and do all sorts of things with it, and it's useful. But as to proving it, the effect, it's super difficult. First of all, like he was trying to describe to you earlier, but at the same time, our current theories of gravity don't actually hook gravity into the small things, like the kinetic molecular theory doesn't use gravity. A lot of our basic science on the super small scale just doesn't use gravity. If we were assuming gravity, like all matter would start to collapse in on itself if we were coming from the matter itself. So it's kind of hard to understand, and that's why Einstein came up with his bending and warping of space-time, and because now you have a bending and warping of a conceptual medium, and you can't measure it and you can't test it. All you got is the effects, and so the medium is just bent to conform to the effects, and that's why it works so well. But when it came to like distant galaxies and star clusters, Einstein didn't work anymore because the galaxies were turning too fast, and the galaxies appeared too old for the Big Bang, and all sorts of things that made the current cosmology kind of fray at the edges. And so we have a lot of people exploring the fringes of cosmology today. We are just the people who are checking the foundations to the cosmology, and once the foundations shift, the whole thing shifts.
Right. So what I've gathered is that dropping something and measuring it is not a valid experiment. It's not real science.
No, it's not a scientific experiment. That's right.
Yeah, it's not a scientific experiment. It's a valid means of you could measure something dropping, and it could be a valid means of gathering information, which could be considered science.
So what is the actual consensus on gravity? Does it exist or not?
Sorry. Richard, can I ask you something? Are you at all familiar with the scientific method, like formally?
Starts off with making a hypothesis, I think, and do an experiment. There's like 7 steps. I can't really remember them now.
Okay. So you, I guess you learned it a little bit in high school. Did a couple things and then had to talk because you changed fields or something.
I'll Google it now. I'll just refresh my memory.
Go for it. And then let's walk through it. Right. If you guys, if I may, you guys, I don't want to interrupt. I want to ensure that Printer understands why we're saying what we're saying here.
Make an observation, ask a question, form a hypothesis, run an experiment, analyze the data and draw conclusions, share your results, repeat the scientific method.
Right on. Okay, cool. So in the context of you take your phone, you drop it, what do you observe? Or excuse me, you take your phone, you suspend it in the air, and you let go. What do you observe?
I see that it falls.
Okay. Second step.
Why does it fall?
Yeah. So what do you propose is the reason why it fell?
Form a hypothesis. Fell because of gravity.
Okay, cool. Does it go into more detail what the hypothesis consists of?
All right. Fell because all objects. I forgot the name for it. All objects act upon each other with a force at any distance.
I was asking, in that outline that you have there, does it show you the constituent parts of a hypothesis? Maybe research that quickly.
It says form a hypothesis. Wait, I need to
Just Google definition of a scientific hypothesis, let's say.
All right. A proposed explanation for a phenomenon. It must be based on observations, and a scientific hypothesis must be based on observations and make a testable and reproducible prediction about reality in the process of beginning with an educated guess or thought.
Perfect. Okay. Does it say anything about the variables? Sorry, guys. I don't
know. I don't see anything.
Okay. Well, basically, your hypothesis, the setup requires your proposed cause for the thing. Okay. And then you have your observation, which is the effect, which depends on which depends on the supposed cause. So you have your dependent variable, the effect, influenced by the supposed independent variable, the cause, right? That you get to control or manipulate throughout the experiment to see if it affects the result. Okay.
Right.
Independent variable, dependent variable, and then you have a single one or a set of other variables that you want to maintain constant. They call them control variables. That might be influencing this entire thing that you try and, to the best of your abilities, control for. Okay.
Right.
You'll find that online everywhere. You might be botching it a little bit with some terminology here, but you get the gist. Okay.
Okay.
Perfect. So in this setup with your phone, you observe your phone falling. What would be the independent, dependent, and control variables in the setup?
The independent would be the fall speed, I guess, or fall time, and the control variables would be,
or even just the sheer. Sorry. But even just the sheer fact that it falls.
All right, the fact that it falls, its a weight, size, atmospheric pressure around it, elevation, I guess those should be all remain constant.
So the weight you can maintain constant. You can probably do it in a vacuum, so you can maintain the air pressure. Humidity also, because it's in a vacuum. Humidity is 0, right? Et cetera, et cetera, et cetera. Okay.
All right. I don't see a problem until now.
Okay. Now, what about the supposed cause, the independent variable?
Well, that's my hypothesis, isn't it? I'm testing it now.
Everything that we've outlined is defining the hypothesis. Okay. There's one critical thing, right? You already said it. I just want you to see the key into the whole. Okay. Right. What is the cause of the effect? Supposedly.
Supposedly, it's gravity.
Wonderful. So there's your independent variable.
Right.
Experiment. What's your setup? What's your method? What are you going to do?
I am not going to do this right now because I'm going to break my phone.
No, I'm not saying drop your phone, dude. Okay.
Yeah, I'm kidding.
Like outline it, right? You got a plan for this shit, right? Okay, I want to figure this thing out.
All right, I'll drop it from 1 meter. All right, and I'll place a stopwatch next to me, and I'll press start as I drop it. How's that?
No, I'm not saying do it, dude. Okay, but now check this out. Now it seems like you've changed the supposed cause.
Why have I changed it?
Okay, so in the hypothesis, if the supposed cause is gravity, right? The Earth's mass pulling it in for whatever reason. There's bendy warpy space-time, or there's some invisible three-toed gnomes pulling down your phone with lassos or something. Who knows? Whatever. Okay, whatever. If that's the supposed cause, but here you are not necessarily manipulating that supposed cause or that supposed variable, but instead changing the height at which you drop your phone, right? You're basically implying that the height is responsible for the gravity. Because that's all you're changing.
What do you mean I changed it? I didn't change it. It'll be 1 meter the first time. It'll be 1 meter the last time.
Hold on. Let me just, can I bounce in here real quick? Brother, you said that your supposed cause is gravity. So we've got all of our controls. The height is the same. The temperature is the same. The air pressure is the same. Everything is consistent. So now we need to perform an experiment to get the dependent variable to occur. So you have an object. And I don't know what this object is. I don't even know what the observed natural phenomena was in nature, but let's just say we have an object. We're trying to make it fall because the falling is the dependent variable. That is the thing that is observed. So now you have to
the independent variable.
No, the dependent variable is the observed effect. It is the effect. The falling of the object is the thing that you saw, correct?
So you disagree with the other dude because he told me that was the independent variable.
No,
he did not.
You misheard.
The dependent variable is the thing that we're trying to cause in the experiment so we can verify our independent variable.
Yeah, fair enough. The dependent variable depends on the independent variable. Right? The effect depends on the cause. Go ahead.
You say gravity is the cause of the thing falling. So now we have all of our controls, we have our object. The next thing you need to do is vary and manipulate the independent variable. In this case, you would have to find an environment that you can add some gravity and take some gravity away to see if adding the gravity makes the thing fall or take away the gravity and it does nothing. Right? So, what is gravity and how are you going to manipulate it?
Why would I have to change gravity?
Because that is the thing that you said is going to cause the effect. So you need to add the gravity to get the effect that you're looking for.
I'll go to the ISS and I'll drop it from there.
Holy cow, dude. What are you talking about? Gravity, what is it?
I've answered this question like 50 times already.
Yeah, well, what is it?
I'll give you my standard response. It's the force that is applied from every object to every other object at any point in the universe.
That's a vague description, and it's just describing something that we don't actually observe.
Did you ask me what gravity is just to disagree on me on it? You already knew what I was going to say.
No, I actually didn't because we get different. Why are you freaking out, bro? bro. I'm being